So before we begin, I just want you to follow along with me here real quick. If I have log base 2 of 2 to the x power, okay? So the base of my log, base of the exponential are the same. Then basically what happens is that the log and the base of the exponential kind of cancel each other out, but I'm putting that in quotes because it's not canceling like we think. What's actually happening here is that the x gets to come out in front. You get x times log base 2 of 2, right? And then we know that that gives us 1. So we basically get to skip that step and say, so that's x times 1. So when the base of the log and the base of the exponential match, then they kind of cancel each other out, right? And that just gives me x, okay? We've talked about that a couple times, just reminding you of that. One thing we didn't really look at is if I have 2 to the log base 2 of x power, basically the same kind of thing happens. I have the base of an exponential raised to a power with a log in it. As long as the bases are the same, those basically, and again in quotes, cancel each other out, and you get x, okay? They're not really canceling out like multiplication, but that's what's happening there. So if I have log base 2 of x plus 3 equals 7. I don't know, just making it up, okay? Then we know that we can rewrite that as an exponential, right? And if I rewrite it as an exponential, I'm going to take the base of the log, which is 2. That would be 2 to the 7th power equals x plus 3, okay? One thing I didn't spend a lot of time on showing you, or probably any time actually, and then as I was going through this lesson, I was thinking I probably should, because it comes up in calculus a lot, and it's going to make something we do today a little bit easier, is basically still getting it into this form, but kind of using one of those rules we just looked at. If I have a single log over here, now remember, if I have log equals log, I can like drop the logs. But I don't have that here, so we would have to rewrite it. But since this is log base 2, if I make these the exponents using this base, so basically I take 2 to that power, right, and 2 to this power, then when these essentially cancel each other out, I'm left with x plus 3 equals 2 to the 7th. You see how it's the same thing over there? And one of the reasons this makes this a little bit easier is because when we're doing inequalities, you would have to flip the sign, and I don't want to have to get into all of that. So let me explain it one more time, and then we're going to do it today too. So let's say that we did have logs. Let's say that we had log base 2 of, I don't know, yeah, I'll just use the same thing, equals log base 2 of x minus 5, whatever, okay? Then one of the reasons we get to drop the logs, that one-to-one property, is because my base is 2. So if I take 2 and raise each 2 to the whatever each side is, when these essentially cancel out and these cancel out, that's why we get this, and we're dropping the logs. You with me on that? So then if I don't have a log on both sides, and I have log base 2 of x plus 3 equals 5, right? I can do the same thing, whatever the base of the log is. So if it's a natural log, I'd use an e. This becomes the base of the exponent so that those cancel out, and x plus 3 would equal 2 to the 5th. You with me on that? That might also be a little bit easier if you get confused when you're going around the equal sign. I kind of wish I had taught it this way from the beginning, and I didn't, because there's more than one way to do a lot of things. But I wasn't thinking about getting to exponentials, and it should work a little bit better. I mean, inequalities. We okay with that? Semi? We're good? Okay. Remember, ask me a question when we're in the middle of it if you need to. All right, this is going on page 80 when we're done. So we're finally getting to the inequalities part that's been in the title of this for days. So we know that previously we solved inequalities. We did polynomial and rational functions. So if you recall, when we had inequalities, we found any x coordinates where we had zeros, wholes, or vertical asymptotes. Okay, so we had to factor and do things and find all that stuff. Then we used a sign chart. So we're back to the sign charts. Anytime we're doing inequalities, and it's not just straight up x is less than 5 when we're done, then we need a sign chart to determine the intervals where the functions are positive and negative, okay? So we can solve inequalities with exponentials and logarithms in the same way, except it's actually much simpler, believe it or not. That's kind of a matter of opinion. There are some things that make it easier, but we have to do an extra step. If you recall, when we started solving logs, we had to take the domain into account, because you remember your parent function for a log looks like this. So our input is not all real numbers. So we have to pay attention to what's going on with our domain. That means that what's inside of here, what I take the log of, has to be a positive number. So I think it's a good idea to start with the domain, because then you're less likely to forget to do the domain, right? So we know we have to take care of the domain. That's what we're going to do over here. So let's just come over here and say, all right, domain. That means that this right here, what's inside that log, what I'm going to take the log of, has to be greater than 0. Has to be positive. So I'm going to say x squared minus 4x minus 12 has to be greater than 0. Okay. So then that is what kind of equation? Quadratic. Am I going to make up math? No, I'm going to. It already has a 0 on one side, so I'm going to factor x and x. 12 is negative, so my signs are opposite. So what would the positive value be? 2, and the negative would be 6. Okay. So from this, I get x equals negative 2 and x equals 6. Like, that's a piece of cake for us, right? So then, for my domain even, I have to do a sign chart, because I didn't just get x is greater than 5. But here's where this actually makes it a little bit easier. So when we did it with polynomials and rationals, we didn't necessarily know what the graph looked like. We know what this looks like, right? When we graph this, what does it look like? Or what's it called? It's a parabola, right? So, and it either opens up or it opens down, right? My leading coefficient is positive, so what's happening? It's opening up. All right, and I know that this is negative 2 and 6. These are my zeros. That is where it crosses the x-axis. And your number line basically is your x-axis. We just leave the y-axis off. So if I think about this, and if you remember when we did polynomials, or even with rationals, we would do the number lines, and sometimes I would like sketch the picture on it to kind of show you what was happening and show you that you could. But it didn't necessarily, we kind of did it after the fact. But here, I know what it's going to look like, and I know those are my zeros, and I know it opens up, so I know that my parabola is going to have to look like that. Would you agree with that? So without me, I don't have to choose numbers. You know how we chose numbers and we tested them and we looked for positive and negative? I know what this looks like, so I know that this is positive, this is negative, and this is positive. Without even drawing it in. I just did that so that you could see it. You with me on that? Because we understand parabolas. All right, so that means for this part, in order for this statement to be true, x would have to be between negative infinity and negative 2, or between 6 and infinity. But we have more than one log here. So I also have to take into account this guy. Now, if it was just log of 4, I wouldn't have to worry about it, but it's log of 2x plus 4. So that means 2x plus 4 also has to be greater than 0. So 2x has to be greater than negative 4. So x has to be greater than negative 2. So my second little interval I have here is from negative 2 to infinity. All right, now I have two domain statements. I either use it all or I use part of it. It depends on what quote wins. And I think for some of you, you might be able to reason through it with just the intervals. But especially the first time, I'm going to show you with a number line, because I think that helped. Not really necessarily a number line like this. So I want you to think about when you first did inequalities way back in the day, and they made you shade, right? X is greater than 2. So you either have an open or a closed circle and you'd shade to the right, things like that. So that's basically what we're going to do with these so you can see what's happening. Okay. I have on here basically -2 and 6. So this says I can use from -infinity to -2. This says 6 to infinity. Okay. So that's that first part. This part down here says I get to use -2 to infinity. Well, all I really get to use is where they overlap. Does that make sense? So if drawing out the number line and shading it like you did, or think about when you were shading inequalities when you graphed them, right? And so you'd have two, don't draw this, but you'd have two lines and you're trying to figure this out and you say, okay, well, I shade this here and I shade this here. So my answer is where they overlap. Y'all remember doing that? That's basically what we're doing on that number line to make it make sense to us. So our domain then overall. So my actual domain that I got from figuring all this out, and then seeing how it overlapped is this right here, and it's just from 6 to infinity. Okay? Questions? Ask me a question. We all good on that? So I wouldn't skip steps. I wouldn't overthink it either. Draw out the number line. There's nothing wrong with it. Shade things so that you can make sure you can wrap your mind around it. Sometimes it's super easy when you have these, or sometimes maybe some of y'all don't need that because you can look at this and it makes sense to you that it's just 6 to infinity. But I know that's not everybody, so just want to make sure we get that. Okay, so now let's go and actually answer the actual question that we haven't even read yet. All right, so we're going to let f of x be all this. And what are all the values of x for which f of x is greater than 0? All right, so let's write that out. So my f of x is log of x squared minus 4x minus 12 minus the log of 2x plus 4 needs to be greater than 0. Okay. Everybody with me? So on the left-hand side, I have 2 logs. Can I combine them? Yes. It's going to become 1 log with what kind of operation? Division, right? Since that's subtraction. So I got x squared minus 4x minus 12 over 2x plus 4 is greater than 0. Now, I'm going to rewrite this. Now, I could rewrite it as an exponential by going around like the quote equal sign, even though it's an inequality. But we're going to think about this like we did before so we don't get our inequalities wrong. Like I just talked about a minute ago. What is the base of this log? 10. So that means both sides here are going to become the exponent where the base is 10. So 10 to this power, 10 to this power. So over here, 10 to the log base 10 power of this, essentially, those go away, and I am left with x squared minus 4x minus 12 over 2x plus 4. Everybody okay with that? Is greater than, what is 10 to the 0 power? 1. Okay. Now, after we were done with the lesson last period and everybody had time to work, I have, even though they don't always talk to me, I do have a table that will actually talk to themselves and argue, and they're funny, and then they argue about who's going to come ask me a question because the other person did it the last time. But I was listening to them, and they're like, yeah, but when we drop the logs, why did this become 1? And blah, 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 blah. So let me just make, and so this is a very good question. I came back up here and I re-explained it. But notice here, I'm not dropping the logs. Like if it's a log on each side, basically they just get to go away and you're left with what was there. It's not like I dropped the log and this magically became 1, okay? Because if this was a 2 and not 0, this would be 100, right? Does that make sense? So it's not just that it becomes 1 every time. Those become my bases, okay? We good on that? Okay. All right, so now the rest is algebra, okay? I've got to figure out what this is, be able to solve for my x here. So I need to get rid of my denominator. I'm going to multiply both sides by the denominator. Since this is 1, I don't have to worry so much about it. But if it was 100, I would have to make sure that I distribute it, right? So just keep that in mind. All right, so this is going to become x squared minus 4x minus 12 is greater than 2x plus 4. So once again, we have a quadratic. We are not going to make up math. We're not technically setting it equal to 0 because there's no equal sign, but we got to get 0 on one side. So I'm going to move everything to the left legally. X squared minus 6x minus 16 greater than 0. Then I'm going to factor. Okay, so x and x. 16 is negative, so my signs are opposites. What would my positive number be? 2, and my negative would be 8. So I get x equals negative 2 and 8. So I'm going to move over here, do my new number line. Negative 2 and 8. Well, guess what? That's a quadratic also. It is a quadratic with a positive leading coefficient, so it opens how? Up. So that means that this is positive, negative, positive. Everybody understand why that's happening? That's one thing that makes it easier because we're dealing with these quadratics. Now I want it to be, it says I want it to be greater than 0. Greater than 0 means positive. So the positive part here goes from negative infinity to negative 2. And from 8 to infinity. But I'm not done because I have to take into account my domain, this right here, which you could add to your number line here if you wanted to, saying, okay, well, 6 to infinity, 6 is like right here. This is all I get to use. So this part is not okay. But since I get to go from 6 to infinity, this whole thing right here is actually in my domain. You with me on that? So that means my answer, f of x, being greater than 0, happens between 8 and infinity. And I'm going to box this, and you might want to on yours just because so you can find it in your stuff. But remember, when we're actually answering questions on the AP exam, we shouldn't box anything. Okay, but sometimes I feel the need to because there's so much stuff and I don't want you to lose it. But even if on the AP exam, if you like, there's so much stuff, they won't find they'll find your answer. Let them find it. Okay, just make sure it's there. All right, so I'm going to ask you a separate question. Let's also look at, so that we can get, work our brains here. And I know it asks for when it's greater than 0, but what about when f of x is less than 0? So f of x is less than 0 here, right? But my domain can only go from 6 to infinity, right? So do I get to say f of x is less than 0 from negative 2 to 8? Where would it start? 6. It would just be from 6 to 8. Okay? Do you see how that works? Using those number lines there. Mario, you okay over there, dude? Yeah? All right. Questions? Okay. Let's flip it over then. All right, we're going to start with our domain again. Come over here, do domain. I know that x squared plus 7x plus 12 has to be greater than 0. That's this part right here. What I take the log of, no matter what the base of the log is, whatever's inside there has to be positive. It's a quadratic. It's already got 0 over there, so I can factor it. And we should be factoring whizzes when it's a is 1. 12 is positive, so they're both positive because 7 is. So my numbers are 3 and 4. So I get x equals negative 3 and negative 4. And I'm going to show you what I did last period when I first wrote it down. I did this. Is this correct? No. I actually did that too when I was working through trying to come up with these equations because I was trying to come up with more examples. But what had really happened is I had them positive when, well, it was other numbers, but I had them positive when they're supposed to be negative. And I was like, dang, they're supposed to be negative. I put the negative signs on there, which then made them backwards. And then I was all kinds of confused with myself. So be careful. It has to be least to greatest. At least I caught myself both times. But so one nice thing about the fact that I don't have to choose numbers is, remember when we were choosing numbers, if it was like this, I'd have to do like negative 3.5, which is not that big of a deal, but that still kind of stumps some of y'all. This is still a quadratic. It is opening up. So this is positive, negative, positive. Since I need this quadratic only when it is positive, my domain goes from negative infinity to negative 4 and from negative 3 to infinity. Any questions about why any of that happens or what we're doing? Okay. So then I also have to do this and say that x plus 4 has to be greater than 0. So x has to be greater than negative 4, which in that case, I don't need a number line if it's just a statement like that. But then this tells me I'm going from negative 4 to infinity. All right, so using that, I'm going to give you a second, and I want you to think about, if I have both of these, what my actual domain would be. Draw yourself a number line if you want to and shade. Do whatever you got to do to make that make sense to you, and then I'll talk about it with you. I'm not going to leave you hanging, but I want you to try and think through it first. Okay, so here's what you can do. If you can't just look at it and know, that's okay. I get to use from negative infinity to negative 4. That's what that part says. And negative 3 to infinity. Then this part says negative 4 to infinity. The only place it's overlapping is right here, right? So my domain that I get to use is from negative 3 to infinity. Okay? Everybody okay with that? Perfect. All right, so that's the domain. I'm going to go back and read the question that I haven't read yet. Let g of x equal this, h of x equal this. I want all the values of x for which g of x is less than h of x. All right, so natural log of x squared plus 7x plus 12 needs to be less than the natural log of x plus 4. Okay, just setting it up. Now, I have a single log on each side, so I can just drop the logs, okay? So I can drop the logs. I'm left with x squared plus 7x plus 12 is less than x plus 4. This is a quadratic. I am not going to make up math. I'm going to put it 0 on one side. I'm going to get x squared plus 6x plus 8 is less than 0. I'm then going to factor. X and x, 8 is positive, so the signs are the same. 6 is positive, so they're both positive. What are my numbers? 2 and 4. So I get x equals negative 2 and negative 4. Do my number line here. Make sure I put them in the right order. And quadratic, right? That's fantastic. Opens up. Plus, minus, plus. This time I'm looking for when this function is less than 0, so that's when it's negative. So it's negative here from negative 4 to negative 2, right? But I have to take my domain into account. You can put that domain, you can put that on this same number line, kind of like we did this, if that is helpful to you. I get to go from -3, which is right here, to infinity, right? So is this interval my answer? No, it's this part right here. G of x is less than h of x from -3 to -2. It would be important in a question like this to make sure that you actually state this, because we have intervals all over the place, right? And so you want to make sure, say like, this is the one I was trying to get at here. This is my answer. Questions? Are we good? Okay, I'll take that as a yes. So number 3, what are we going to start with? Domain. All right, so I'm starting with my domain. I know that x squared plus 1 has to be greater than 0. Now, before we just jump in and do algebra for the sake of doing algebra, is there any way using real numbers to make that not greater than 0? I'm going to take some number and square it. Won't this be some positive number? Or it could even be 0. But if I add 1 to it, it's going to be greater than 0 all the time, right? There's really no way to make it not greater than 0, because I'd get imaginary numbers if I do all that. So really, this part of the domain is just negative infinity to infinity. Then I got to take this guy into account. So 5x minus 5 also has to be greater than 0. So 5x has to be greater than 5. X has to be greater than 1. Which means that this goes from 1 to infinity. So I would think, I mean, you can. I don't know that you necessarily need a number line here to figure that out, right? Where they overlap. Because where all real numbers overlaps with 1 to infinity is 1 to infinity. Everybody good with me so far? Okay. So then, let's see. I got h of x, k of x. H of x is going to be less than k of x. So natural log of x squared plus 1 less than natural log of 5x minus 5. Can I drop the logs? Yes, I can. So I'll get x squared plus 1 less than 5x minus 5. Quadratic, move everything over. X squared minus 5x plus 6 less than 0. Factor x and x. 6 is positive, so the signs are the same. 5 is negative, so they're both negative. What are my numbers? 3 and 2. 6 and 1 are, it's tempting, right? But not when the signs are the same. So I get x equals 2 and 3. So here's my number line with 2 and 3. This was a quadratic that opens up, so this is plus minus plus. And less than 0 means we're looking for negative. So we're looking for between 2 and 3. And then my domain says I can go from 1 to infinity. Well, here's 1 right here, 1 to infinity. So it looks like I get to use the whole 2 to 3. We agree with that? So I can say h of x is less than k of x from 2 to 3. What questions do you have? We good? Lots of work on one question, but you can do it. Just make sure you don't forget about the domain. Draw out number lines and shade for yourself. I think you'll be okay.